write out my formula. Oops. Do this first, move this over. Twice the area of my base, perimeter of a base times how far apart they are. And I label everything. Big B is a rectangle, which is base times height. In this case, I'm saying it's a 2 by 3. It's easy, it's 6. After that, I figure out the perimeter. Well, if the 2 by 3 is my perimeter, that means I have 2 sides of 2 and 2 sides of 3. So my perimeter is 10. Yep.
Hold on.
And then how far apart are they? 8. Put it all together. Twice the area of the base, plus the perimeter of the base, times how far apart they are.
Wait, why do you subtract the rectangle?
I'm not subtracting anything. It was.
Oh, it's all
Yeah, it is a rectangle.
Okay, absolutely.
Yes, sir.
So if you use the whole bottom and the top as your bases, you use the same.
You get the exact same thing. Yeah, and that's why the rectangle ones are the oddball. You really can't screw up which one's the base on a rectangle. All right. Now, everything else you will screw up. This one you really can't. All right. Yes, ma'am.
How did you get 10?
How did I get 10? 2 plus 3 plus 2 plus 3.
Because you know how
I'm going the perimeter of that base. I have 3 plus 2 plus 3 plus 2. I'm just adding up the sides to get the perimeter. When we're looking at the perimeter, it's going to be the perimeter of whichever one I'm calling the base. Now, like Siobhan was saying, if I use that bottom one, the 8 and 3, it would have been 8 and 3, 8 and 3. I would have had a different perimeter, but then I would have had a different height. But it all would have worked out to be the exact same thing of 92 something squared. All right? Yes, ma'am.
I'm confused on the steps that you took because you were doing
Which one? What the shape was?
no, like following the steps. Like I just got confused, right? Like when you were writing the 2b plus ph, I got confused.
That's the formula that we talked about yesterday.
Yeah.
For every one of these has the same exact formula. They all start with twice the area of the base times the perimeter of the base times the height. The formula for all of these is the same. What changes is the shape. The case in here, the base is a rectangle. So I wrote down the formula for finding the area of a rectangle, base times height. Filled it in. Found the perimeter of that base. 3, 2, 3, and 2. And I wrote it down and I got my 10. Excuse me. And then how far apart are they? 8. I just put it all together. Okay. Let me get to the next one and you'll start to see it's not as crazy as what you're probably thinking. Okay. Yesterday I gave you guys a hint about setting up the triangle one. When you set up the triangle, you have equilateral. What does an equilateral triangle's height do to its base? Cuts it in half. So if the whole thing was 3, that makes each individual part 1.5. If you know a hypotenuse of a leg, what do you use to find the height? That right there. So in this case, you have your height squared plus 1.5 squared is your 8 squared. At this point in time, you should be able to just go right to your calculator and just type in 8 squared minus 1.5 squared, and then take the square root of your answer. And I get 7.86. 7.86 is what I would round that to for the height. And now, that was the hint that I left you guys with yesterday about how to start it. Write out your formula. Triangular prism, twice the area of the base, plus the perimeter of that base, times how far apart they are. Well, our big B is a triangle, which means it's a 1/2 base times height. I now know all of those parts. I give you the hint of what to do. It'll be the area of that triangle then equals 1/2 3 times 7.86. That's how I got that. The perimeter of that base, which is a triangle, is going to be 8, 8, and a 3. 19. And then the last bit was the diagram says they are how far apart? 9.1. Oops.
Wait, how'd you get a 1.5?
The height of an equilateral triangle bisects the base.
Oh, okay.
Okay. So now I have, this is what we were saying yesterday, is that we're going to break this into 3 separate parts. Breaking it into 3 separate parts becomes a little bit easier to put it together because now you can just write the whole thing out. Twice the area, oops. Twice the area of my base, 1/2, 3 by 7.86, plus perimeter times how far apart they are. 2 times 0.5 times 3 times 7.6 plus 19 times 9.1. 196.48? Sound about right? One of the things you can do with this part, notice how I typed in, when I'm doing that parentheses portion, where it was 2 times 1/2 times 3 times 7.86. Yeah. Yeah, hurry up. When I type that in the calculator, since there's no addition inside that parenthesis, I just type 2 times 0.5 times 3 times 7.86, and it works out just fine. It'll be just fine to do it that way if you'd like. All right. If you're getting mixed up with all your parentheses, you don't have to worry about that. Does that help? So, Kayla, if you were typing that in and getting it a little goofy, what's going on? If you did that, if you're messing up with the parentheses, since it's straight multiplication, just put your times. It'll
Marcus Bobo.
he's taking a test. He's right outside the next right now.
Thank you.
No problem.
You know, big can you scroll first and come out as 2 little ones, and then it wasn't going over the whole length.
Stupid parentheses. But here's the thing: did you write down what you were about to put in the calculator? That makes makes all the difference in the world. And guys, if you write down what you're about to put in the calculator, I know what's going on. Okay, I've got like 2 pages left to go on the tests, and that happened. That happened a lot of times. People wrote down what they were doing, but they typed something in incorrectly. But I knew you knew what you were doing. It happens, and that's what I want you to do. Yes, ma'am.
So, do you take off points if you did the work right and you typed it in the calculator wrong?
No. And that's the whole point of showing all your steps. I've been saying this since, August.
No, wait, hold on.
Here's the thing. Let's say you wrote, ladies and gentlemen, let's say you wrote down all of this, but you accidentally typed in, instead of 19.91, let's say you accidentally typed in 19 times 91, and you gave me an answer. Obviously it's wrong, but what did you screw up? You didn't screw up, you just forgot to put a decimal in. You know how to math, you just don't know how to press buttons. Yes, ma'am?
Yeah.
Yeah,
that's
he's
what I was
like- he's
wondering.
It's just a joke, because it's like been doing this for a while, like it's like time.
Must you have a calendar on there?
Actually,
I do.
Trevon had rights to.
Really?
Never buy a watch without a date on it. It's just silly.
Why do you say silly?
Because you're always, I don't know, as a teacher, people are like, what's today's date? What's today's date? And then it's easy to just look at my watch and say, oh, today's the 12th.
No, today's the 13th. I'm kidding.
All right. Last one that I had you guys do last night was the Pentagon.
Yes.
Just like the one we did in class. So in your notes, you already had the setup. You already had the setups as far as how you work with your perimeter apithel. In this example, again, we start by writing down the formulas, just like we have been. This is twice the area of the base plus the perimeter of a base times how far apart they are. Well, the big B in this case is a pentagon, which means it's a 1/2 perimeter apithel problem. Okay.
What is apithel again?
What?
Anyway, we'll get to it. So whenever we did these problems for the past 2 or so weeks, we would do this. And we'd fill in the blanks. 2, the apithel bisects, and we'd have to figure out our angle.
Can I write this down real
Oh my God.
It's the same problems we've been doing.
quick? Yeah, I know, but it's just like,
It got
Now-
switched up.
Just go over it.
Guys, as we go through this, the steps haven't changed. You start by taking the number of sides. Take 360 divided by the number of sides. You get 360 divided by 5, and you have 72. Draw the radius. That gives you the entire interior angle of 108. The radius cuts it in half. Half of 108 gives you 54. You need to figure out your apithel. You know an adjacent, you need to find the opposite, which means you're going to use tangent. Don't eat here, they've been yelling at me for the food. Thank you.
138.
Now in this case here, I'm dividing it by 1. Will that change anything? No. So if I multiply both sides by 1, it doesn't change anything either. This is the case, and I don't have to really even worry about it. So my apithel is going to equal whatever the tangent of 54 is. It's just some decimal. All right? I also know that I have sides of 2. If I have sides of 2, that gives me a perimeter of 10. So my big B is going to be 1/2 perimeter times my apithel, which is tangent of 54. And I'm just going to leave it like that for right now. Okay? I don't have to worry about decimals and rounding yet.
If you did get that.
That's fine. Now, I also know what the perimeter of that base is because I just wrote it down. It's 10. And the diagram tells me how far apart the bases are. It said that the bases were 3.5 apart. So then you write it all out. Twice the area of your base, 1/2, 10, tangent, 54, plus 10 times 3.5. We come back to the calculator. Since I am just, everything on the big B side is all multiplication, I don't have to worry about parentheses. Also, by leaving it in terms of tangent, I don't have to worry about rounding error. I can just do 2 times 0.5 times 10, tangent 54. And that gives me that first part. To that, I just hit plus 10 times 3.5. 4876.
Oh, yeah. Oh,
Okay? That's how this stuff goes.
That's all it is.
It's like that simple.
It's the same, guys. It's the exact same thing we've been doing for the past 2 weeks. I'm adding what amounts to 2 steps. Okay? I'm adding what amounts to 2 steps. All right? Question? Which gets us to cylinders. There you go. Yeah. I'm like, yeah, it didn't look right. Cylinders. Still doesn't look right, but.
So Landers.
As I said, I am nothing but a great artiste.
It looks like a
It's bad, I know.
cake.
I used the last one for homework.
Now, what changes here between a prism and a cylinder is what are the bases of every cylinder?
Oh my god.
Circles. All right. What's the area of a circle? Pi r squared. Now, here's the thing. If I think about it in terms of a cylinder, if we go through cylinders, same deal. Twice the area of the base, perimeter, and how far apart they are. But in a cylinder, your base is always a circle. Which means the area of a circle, does that formula ever change? No. The only thing that changes are the numbers. Okay? So the area of every circle is always pi r squared. So this will always be a pi r squared. Perimeter of a base. Perimeter of a base is always adding up the sides. But when you're talking about the perimeter of a base of a circle, what do you call the perimeter of a circle? The circumference. What's the formula always for circumference?
2 diameter.
Yeah,
Pi.
or just 2 pi r, or pi times diameter.
Yeah, pi.
So perimeter is always the circumference, which is always 2 pi r. How far apart they are is just always how far apart they are. Which means you could actually shortcut the formula because it'll never change. The surface area of a cylinder is always 2 pi r squared and 2 pi r h. Where the h is just how far apart are the circles. The other two parts never change. But you can see how it works out to being twice the area of a base, perimeter, and height. They're same, but in a cylinder, they're always circles. So it becomes a little bit easier. Okay. Becomes a little bit easier to set up. Which means you have pi in answers. That's it. Okay? You'll have pi in your answers. Your calculator does all of the work for you on these. Cylinders are ridiculously simple to work with. Yes, sir. Yeah. You got your thing? Yeah. For example, I'm gonna cheat.
Ice cream cone.
We do those next week.
Okay. Yellow.
So if I have a radius of 6 and a height of 15, it quite literally is just putting things into the equation. There's a lot less craziness involved with cylinders. So what happens here is if we go back to the idea of how you write it out and how you just put it in your calculator with specific order. Remember how we put pi's in front of variables, but then when numbers are involved, pi is after numbers? So really what happens now is we just change this to 2 6 squared pi plus 2 times 6 times 15 times pi. Now, if you're using your calculator, when you type that through, it's going to look like this. 2 6 squared, and then a pi, plus 2 times 6 times 15 pi. You can type it so that it looks just like this. If you type it like that in your calculator, your calculator will give you the answer in terms of pi. It'll keep pi in your answers, which is the exact answer. No rounding, no nothing, have to worry about it. All right? You don't have to worry about parentheses for this one. So you have 3672. What is that? 3180. I believe it's 252 pi.
Yeah.
And you just label your answer. Okay. Working with the cylinders is the easiest one that we do, because it quite literally is going to be just put numbers together. I think the goofiest thing they might do to you on these things is they might give you a diameter to start with. Oh no, I have a diameter, I need to find a radius. That's about as crazy as some of the stuff gets. All right. But yes. But same thing with stuff that we've done before. Whenever we had area problems, you could always work backwards to find a part. We still do the same thing with this stuff as well. I only have 2 more examples, and I've got a bunch of stuff to hand out to you today. For example, let me get to it real quick. Oop, passed it. What's that?
We have to draw that.
No, I really don't think drawing these things is so hard. But what I want you to be able to do is tell me whether or not it's a prism or a cylinder.
Okay.
Which is it? Are you sure?
Yes.
Double sure?
Sure.
Triple sure?
I don't know.
I'm messing with you.
Hey.
Okay.
Make them rethink it. So I never
Stand by your conviction. Say yes, damn it. It's a. I almost said a cylinder. I'm saying it again. It's a prism.
Well, the teachers are
The
like,
icebox.
well, like when you say an answer, they're like, "Are you sure?" And then you're like, say the other answer, and they're like, "Oh yeah, you're right." But you say, "Yeah."
Haven't you figured out that I'm just getting annoyed that
No,
it's
I
not
never
out
know
here?
when you're joking or when you're.
That's what's good.
No, that's not what's good.
So we got a prism, okay? We have a prism, it's rectangular. So what we want to do is write out the formula, okay? We know that a prism is twice the area of the base, perimeter of the base, and the height. H is how far apart are the bases. Now, earlier today, when we looked at that example of the rectangular prism, remember how I said it didn't matter which one you called the base? It doesn't, but here's the thing. When you start thinking about this, this is going to be 2 of a base times height plus the perimeter times how far apart they are. Which of these would make the most sense to make this value? Would it make it a part of the area, part of the perimeter, or just how far apart they are?
What does that say?
Yeah.
What?
After the P.
How? I was asking how far apart they are, because I didn't want to call it the same thing. What happens a lot of times with these things, if possible, make the unknown the height, how far apart they are. Which means then your base is going to be the 7 by 5. Does that make sense?
Yeah.
So I would start right now. I know it's a rectangle, so it's going to be 2 times a base times height, which is 2 times the 5 by 7. The perimeter is going to be the 5, 7, 5, and a 7, otherwise known as 24. Okay? So the perimeter is 24. How far apart they are is what we don't know, but what does the surface area have to add up to equal? 142.
Where did you get
Yep. Because we don't know how far apart they are. So what's 2 times 5?
10.
10 times 7? 70. So you get basically what amounts to being a two-step algebra problem.
Oh, so you don't like distribute, you just like multiply it out?
Yeah.
Oh, okay. That's what I kept getting confused from, because I'm like, I see
There's-
parentheses, but you're not.
Yeah, when you only distribute if there's a plus sign. Since this is all multiply, just multiply straight across.
Oh, okay.
Okay.
I got you.
So you have to move the 71st. Yes. Move the 71st. How do you move it?
Subtraction.
Subtract it. So you have 24x is 72. Divide it out and you get? You set them up like that. All right. Let me do one like this with the cylinder because sometimes with the pi button it can get kind of messy, and then we'll call it a day.
No, wait.
I can't stop.
Do you have any paper?
Yeah, I'm running out though. I used my last piece last night.
Yeah,
There's scratch paper back there. Help
I
yourself.
have 3 left. Yeah, I just have to
Homework.
find. Literally, it's all those binders math.
Well, we still have math to go, so you're gonna need paper.
No, when my paper math ends. Just kidding.
Like my heart.
Me too.
No, I did the.
All right, same idea. Shh, ladies and gentlemen. Psst. Stop. Same exact thing happens here. Same exact thing's going to happen here where we have the surface area of a cylinder. I know the radius. I got to find the height. Okay? So what we do is we start by writing out the formula. Just like always. 2 pi r squared plus 2 pi r h, and that has to equal 326 and change. Okay? Well, according to the diagram, what's your radius? 4. So we rewrite it. 2 times 4 squared times pi plus 2 times 4 times pi times x is 326.73. Are we okay with that? Now we have to be careful in how you type things in your calculator. What I would suggest that you do from the next part is to simplify the stuff with pi's and rewrite the equation. 4 squared is how much? Double that and you get 32. Okay. So we start with a 32 pi. 2 times 4 is 8. Now, that 326.73 obviously had pi thrown into it somehow, but I don't know what it was because it just gave me a decimal, which is fine. Do you guys all agree that the first step would be to move the 32 pi? How would you move that? Subtract. So in your calculator, you would do 326.73.
Clear
Oh,
first.
thank you. 326.73, and I'm going to subtract. Now, when you have stuff that has pi next to it, you need to put that part in parentheses. It was what, 32?
Yeah. Oh, yeah.
I have to put that 32 pi in parentheses. Yeah. And that gives me, yes, sir?
Wouldn't you combine my terms?
I can't, because the 8's got a variable.
X.
It's got the x. Okay.
Oh, I did it without parentheses first.
Some calculators work, some don't. I'm just defaulting it to making sure it covers everything. Okay. Now, you have another crummy decimal. That crummy decimal equals 8 times pi times x, which means I have to undo multiplying by 8 pi, so what would I do to this? Divide it. And again, when you divide it, you have to make sure in parentheses, and you do that. And that should give you how far apart everything is. 9. Okay. And that's how this stuff is going to work. You should get relatively clean numbers a lot of times with this. What's up?
If you get like 9.000, would it just be 9?
Yep, exactly. Yeah, because even if I round this up and there's 100th, it would be 9.
9, okay. Okay.
So don't get don't get scared, don't get lost in the algebra. It's not like it's going to be horribly bad. It's just a matter of setting up your stuff in the right order. With that, I've got 9 of these for you this evening.
Whoa, that's crazy, because the last problem.
I like today's a Monday.
Convenient. Yes, sir.
When I was killing you.
Yes, because that's how far apart those circles are. That's what that means. I spaced this out for you guys. I spaced this out for you guys on this, that way you can just kind of write it all in here. You should have plenty of room here to be able to do that. What's that? Like I said, I spaced this out on here for you guys.
Just kidding.
You'll be able to put them all on here, and you'll notice, ladies and gentlemen, hey, look at that. Another pentagon. Huh. Okay. And you might also notice that there's something given to you in the pentagon that you might not even need to use. Trig. Get these 9 done. There are 3 of each. There's 3 cylinders, 3 prisms, and 3 algebra style. Okay. Also, I want to explain to you your optional project. Yep.
I'm doing it.
Yeah. Thank you for reminding me.
I had to go back and just
Well, it did at least give you the beginning.
It's like beach when.
Because we're going to start prism, not prism, sorry, pyramid, which is, guess what? Formula.
So, yeah.
I don't know why you can try sometimes. And I will explain this to you guys. Over the course of the years of doing this, I have used different dimensions, I've used different setups, different values, and all.